epoch, a point in time beginning a new or distinctive period. The epoch system sets new standards in design integration, innovation and flexibility. The system incorporates the highest technical state-of-the-art design features, making it the most integrated and powerful gaming computer currently available. The infinitely adaptable input and output structure allows for a new and far more efficient approach to customer and engineering support. Above all, the system has been designed to be the most reliable and easiest system to operate. The basic configuration of the system comprises of 5 boards. The main processor board, coin mech and stakes and prizes board, payout and meter board, wheel driver board, and front door board, which controls the lamps and game switch inputs. Let's look at the main board. In the center of the main board is the Application-Specific Integrated Circuit, or ASIC device, which is the heart of the system. This ASIC device controls all of the inputs and outputs and communicates to the other boards via the ribbon cable I/O link. This device controls every part of the Epoch system. We'll explain the operation of the I/O link in a moment. There's a boot micro PIC device, which works in a similar sort of way to that of a BIOS in a personal computer. When the system is initially switched on, the boot PIC gives the ASIC device instructions and checks the stability of the game software. If the game software is not recognized, the system will not enable. The services this provides will protect against tampering with original games and Maygay's intellectual properties. There's a second PIC device on the main board, which is responsible for the real-time clock and machine security functions. This provides all time counters, including day of the week and full year. It automatically adjusts for leap years and is also year 2000 compliant. There are 4 game Eeprom sockets on the main board, where it's possible to fit 1, 2, 4 or 8 MEG devices. These sockets are configured by the boot-up microprocessor, thus not requiring any links or jumpers. In addition to this, further memory can be added up to a maximum of 14 meg by incorporating a special adapter. This is fitted into the normal Eeprom sockets and is also configured via the ASIC device. Beneath 2 of the Eeprom sockets are 2 RAM devices, which provide 64K of non-volatile memory. There are also sockets for 2 sound Eeproms that can have a combination of 1, 2, 4 or 8 meg devices installed. The configuration for these devices is done exactly the same as for the game Eeproms via the boot-up PIC. Also incorporated onto the main board is a Yamaha 8-channel ADPCM PCM device, which provides the system with its sound. This device can generate audio that has individual stereo and pan controls. The board has full stereo output capability that's driven via 2 high-quality power amplifiers. These can provide continuous power on both channels up to a maximum of 5 watts RMS. The Epoch system provides support for up to 4096 direct outputs via the I/O link interface. Because these outputs are written over this interface, only the number of outputs required in a particular game need to be installed and configured. All activity is performed by the ASIC and requires no support from the primary microprocessor. The outputs and the number of blocks activated is fully controlled by software. Each block is written from the RAM in 156 microseconds, which is 6,400 times per second, and sent around the system via the ribbon cable link. The ribbon cable link is basically a high-speed serial interface, which has 5 channels of information. Each channel provides the system's boards with the relevant information to enable them to run. The information is delivered via a clock signal and activated by a strobe. There are 2 full-featured independent serial communication channels provided via the primary microprocessor. These channels can be operated in async mode at baud rates up to 38.4 kilobits per second. Both channels support selectable data length, stop bits, parity, multiprocessor bit and baud rate. The first channel has an industry standard female 25-pin D-type connector with power supply pins as used for industry data logging equipment. The second is supplied through a special connector that also has the TTL direct drive lines for both serial ports, as well as the RS-232 levels for the second channel. Also included on this connector are the plus and minus 12 volt supplies. I2C interface. This interface is an enhanced I2C 2-wire port, which serves several different purposes. It's capable of not only operating at the standard 100 kilobits per second, but also 400 kilobits, the higher standard, and the special proprietary 1000 kilobits per second mode. One of the onboard devices that uses this interface is the Eeprom. There's a socket provided on board for this device. This device gives long-term parameter and game configuration storage and can be used to hold site-relevant data as required by some applications. The Epoch design has a number of different power supply monitors. The first times the line supply period, detecting missing cycle bursts, and will initiate a system power down if more than 8 cycles are missing in succession. A second monitors the power supply good signal. The third is not actually a power supply monitor, but is the spark detect circuit. This will measure the period of any electromagnetic interference, and should this fall outside a predetermined window, will cause a power down of the system. A powerful feature of the Epoch system is the provision of a multi-mode matrix display port. This can drive several types of matrix display panels. The port is directly operated from the ASIC device and requires no support from the primary microprocessor. The DIR switches are also mounted on the main board for easy access and are read at an I/O frame rate, approximately 100 times per second. There are also LED indicators to give indication of the voltages present on the main board and status of the system. The security LED flashes to display the boot pick has successfully configured the system and has enabled the primary processor. Front door board. This board is designed to drive all of the lamps and switches mounted on the front door of the machine. The power is connected at plug 4 and provides plus 5, plus 12 and plus 36 volts DC. The ribbon cable link from the main board connects to location PL1, the link input. All input and output operations of this board are taken from the I/O link cable. Other information not required is transmitted out via PL2, the link out, which in turn is connected via a ribbon cable to the coin neck and stakes and prizes board. Plug 9 is the lamp outputs for the lower glass and plug 10 is the lamp outputs for the upper glass. The lamp drive transistors are overrated to ensure reliability and performance. There's also an open circuit lamp detect facility, whereby the machine is able to identify a blown bulb and report the condition to the software. The play switches are directly connected to plugs 5 and 6. Because the design of this system uses direct inputs, there is no longer any need to have diodes connected in series with any switch. There is provision to drive 2 alphanumeric displays directly from this board, which are connected to plugs 7 or 8. If only one display is used, it's connected to plug 7. LED displays are connected to plug 3, which is a 16-way connector. This output can drive up to 64 segments. The refill meter is also connected to this board via plug 11. In normal operating conditions, the status LED in the center of this board, the system heartbeat, flashes to show the board is functioning. Coin neck and stake and prize board. The purpose of this board is to look after the coin acceptor and stakes and prizes keys. The power for this board enters at plug 7 and provides plus 5, plus 12 and plus 36 volts DC. The ribbon cable link from the front door board connects at location PL1, the link input. All input and output operations for this board are taken from the I/O link cable. This board has the industry standard 9-pin D-type connectors fitted for the stakes and prize and percentage keys. The coin mechanism and divert lines are also connected to this board, along with the illumination lamps for the coin neck bezel. This board also incorporates a status LED to show the system heartbeat and that the board is functioning. Other information not required is transmitted out via PL2, the link out, which in turn is connected via a ribbon cable to the reel driver board. This board is used to drive the reels in the machine. The power is connected via plug 3, which supplies +5, +12 and +36 volts DC. The ribbon cable link provides this board with data at plug 1, and any information that's not required is directly linked out on plug 2 and driven onto the hopper meter board. The standard AWP reel driver board is equipped with 4 outputs that are connected to each reel module by the means of a short harness. A 6-reel driver board is available if a product should require it. Once again, the board is fitted with an onboard system heartbeat LED to show the status of the board. The final board in this chain is the hopper meter board. The information required to drive this board again comes in via the ribbon cable link on plug 1. The power connects via plug 3, which supplies +5, +12 and +24 volts DC. The hopper refill and test buttons are connected at plug 7, whilst all other door switches connect to plug 6. Plug 5, an 8-way connector, drives the 12-volt mechanical meters. There is provision for a note acceptor to be connected at plug 4. Like all the previous boards, an LED system heartbeat indicator displays the status of the board. Due to the hopper security issues Maygay have had in the past, this board is now shielded with a plate and shroud to improve protection. The power supply used to drive the Epoch system uses switching regulators for efficiency and reliability. The unit also isolates the +24 volts DC from the hopper at all times until the machine requires to pay from the hopper. This is done to combat the criminal fraternity shorting the hopper unit or driver board to ground and will provide greater protection. There are also LED indicators to identify the voltages present on the power supply. There is an LED for the +36, +24, +5, +12, -12 voltages, and one for the sync signal that is used by the watchdog circuit on the main board. If any of the system boards should fail, the heartbeat LED indicator on the board may give an indication to the status of the board. The engineer should examine the connections closely and correct any suspect wiring or harness connections. There are no serviceable components on the Epoch system boards because, once again, it's been engineered in such a way to minimize failure. With the use of the correct aptitude and prudence, the system will be self-supportive. This system is modular, which basically means that if a board should exhibit a fault, a replacement board can be fitted with ease and at a much lower cost than a complete microprocessor unit. Test routines. To enter test is simplicity itself. Hold down the test switch followed by pressing the function button on the main board. Release both buttons and the machine will go into its test routine. You'll notice that the 3 game buttons on the right-hand side of the machine are flashing. The middle button will advance you forward through each of the tests. The left-hand button will step you backwards through the tests. To enter the test you require, you simply press the Start button. Let's go through each of the tests. Test 1.1 is the coin-in test. Press Start to enter and exit. Test 1.2 is the coin-out test. Test 2.1 is the reel test. Test 2.2 is the reel soak test. Test 3.1 is the auto lamp test. This will report any blown lamps in the machine. Test 3.2 is the full illumination test. Test 4.1 is the switch input test. Test 4.2 is the dill switch test. Test 5.1 will test the alphanumeric display. Test 6.1 will test the meters. Test 7.1 will establish the communication to any of the industry standard electronic data capture units. Test 8.1 will test the sound output. Test 8.2 will give the user the option to adjust the volume level of the machine. The refill key will give the operator many options, such as refilling coins, last bank recall, and last win recall. To check the float level on the machine, the operator must have both upper and lower doors open. The error log can be accessed with having one door open. To float the machine is simplicity itself. There are two ways to carry out this procedure. The first way, when the machine doors are closed, turn the refill key and insert the coins through the coin neck to the value of £125. The second way is to manually drop £125 coins into the hopper, open the front door and turn the refill key, followed by pressing the hopper top-up button on the hopper unit.